Welcome, and I just want to actually start before I begin the tutorial in promoting ReproRehab, which I forgot to do when I started the tutorial, but it wouldn't be possible without this program. ReproRehab is an educational program funded through the NIH, all thanks to the great PIs that have put this together, and I am a TA who's part of it. So please come to the site, check it out. There's going to be a lot of new and interesting material coming as the course continues to build. I'm going to post a link to ReproRehab and the Neighborhood Atlas in the description. So please come by and enjoy. Thanks. Bye. Hi, my name is Dr. Andrew Hyman, and today I'd like to show you how to use the Neighborhood Atlas and import all of the data within that atlas to be merged with participant level data on the 5-digit zip code level. So first, let's talk a little bit about the Neighborhood Atlas. The Neighborhood Atlas comes from the Center of Health Disparities from the University of Wisconsin School of Medicine and Public Health. And if you're not aware of what this is, I really encourage you to look into it. Essentially, what this group has done is, at a very granular level, is looking at this measure of disadvantage, or really it's called ADI, Area Deprivation Index. And it really talks about all of these different socioeconomic factors combined into a single score that can be used to summarize the level of accessibility or other types of metrics that a person who lives within a specific region within the United States may or may not have. So let me show you an example. So we go to the mapping. I'm just going to select Alabama as a state that we can kind of look and zoom in on in particular. And you can see that here I'm looking at all of the data color-coded by, I think this is probably 9-digit zip code in Alabama. As you can see, there's just a lot of diversity within here. And specifically what we're looking at right now is the state-only deciles. So individuals who have a more blue color are considered to live in areas that are less disadvantaged. Individuals who live in a more red color live in an area that is more or the most disadvantaged. And this here is what we're rendering based upon the state level data only. So this is only the deciles within the state of Alabama. We can look at the national level, and you can see how the colors change when we now are referencing each of these different areas dependent upon how they measure up compared to the rest of the country and their level of advantage or disadvantage. So now I can zoom in here to, say, Montgomery, Alabama, and I can see a variety of areas that are very undisadvantaged or have the least amount of disadvantage, right next to or adjacent to areas with moderate disadvantage, to perhaps some of the most disadvantaged in the national percentile. Now, right now, as this API is set up within the Neighborhood Atlas, the best you can do is really be able to enter in a full address to then be able to get the overall national or state level percentiles or deciles for that area. There's no way currently to be able to just put in a zip code, or whether it be 5-digit, 9-digit variety, a census tract, other kind of longitude or latitude, things of that nature, and be able to do some kind of batch processing where you can put in all of these information that you have from your participants and get out the specific data for yourself. But what you can do is, once you've registered, you can download the data yourself. And there's really two ways to do this. I already have a login, so I'm going to log in here and show you kind of the back end of it. And you can use the site, you can use the mapping function, or you can use the download function. We'll go into the download function. And we can either download the data based off the 12-digit FIPS codes. If you don't know what FIPS codes are, I had to learn about them myself. They kind of very involved. Or 9-digit zip codes, and this is the one that I went with. And you can either do it on the kind of national level, or you can do it So if you do FIP codes, you can do all states all at once, and you don't have to do it a single state. If you do the zip codes, which I did, you'll have to download each state individually. And that's what I ended up doing, and I'm using the 2020 version. Okay, so now I have, when I download them, and I'll show you what it looks like, I have one folder that's going to have each of these individual state directories that I then am going to try to access and merge with my data within R. All right, so this is a very kind of straightforward way to be able to get your data. Why did I go the 9-digit zip code versus the 12-digit FIP code? Or why did I do it a single digit? Well, I found that, or why did I do it by single state? I found that by doing by single state, you actually get more data. You get more kind of geographical locations compared to if you just did FIPS code and just decide to do all states. So although this requires you to do something like 100 total clicks to be able to get all 50 states downloaded onto your machine, I think it's well worth it, because then you have all of the available data that the Neighborhood Atlas has available. Okay, so this is what the overall process looks like to be able to use the Neighborhood Atlas. I'll give you an example now of what that data looks like. So I downloaded all of the data, and I have it now within a single folder on my machine. I call it ADI all zip, and I get, as you can see here, I have 52 because it also includes things such as, I think, the Virgin Islands, something like it, some other, Puerto Rico, and one other, a District of Columbia. That's why we have 52. Okay, so it's, it goes beyond just what is you kind of consider the normal state level data. And then what we have here is, if I go into one of these, I have a README file that's associated with each one of them, and then I have a CSV file for all of the state level data for the specific day. As you can see here, the abbreviation AL, this is for Alabama. So here you can see the total number of records within here, and that it says, and then it tells you in this README file exactly what kind of data you can expect to find. So there's zip4, which is the 9-digit zip code ID. The FIPS is also there, the GIS join, the ADI national rank, and the ADI state rank. So I'm going to open this up and see how this looks. And it's already telling me, so I want to share this with you really quickly. It won't let me drag it across, but because there are, as you can see here, over 1.5 million entries in the Alabama dataset alone, Excel actually cannot open this much data and render it in an Excel sheet by itself. So as I bring it over here, as you can see it in this format, if I just said highlight this, the total count is actually a little more than 1 million data entries. So using Excel to be able to explore these data is really infeasible. Excel is not really designed to be able to do this given this much data. And if you want to look across it for all states, as you can see, places like Texas have over 5.5 million entries. It's just too much data for Excel to handle, in my opinion. There might be other ways around that, but I'm just not familiar with them. So this is what the data look like. So essentially what we're going to do is, in every 9-digit zip code, we're just going to grab the first 5 digits and create an aggregate and merge it with our 5-digit zip code that we have at the participant level. Okay? And we're going to do this for all 52 files that we have, so all 50 states plus Puerto Rico and the District of Columbia. All right, so I have them all here. You have an idea of what the data looks like. You have an idea of what kind of variables are within the data. So overall, it's a very simple data set. Only has a handful of variables in them. All right, the ADI national and the ADI state. All right, don't save. Can exit out of this as well. So here I'm going to show my R environment. And what I have is, I've already run this code because it can take a bit of time, and I don't want you to just have to watch this being rendered or having this to actually process through each of these files. But I will walk you through what each line does. So first I have my own data here, which I just called my zip, which I've read in from my kind of overall parent directory, the ADI all zip folder. Now if we look at the MyZip, what I have is essentially the 5-digit zip code in numeric form and the state level abbreviation as well. All right, and I'll kind of show you why I like to have this as kind of a sanity check at the end. And what I want to do is essentially take the zip codes within the MyZip data frame and be able to merge them with the individual zip codes within all of the ADI data that I have. Now the issue is that I only am going to be able to, I'm not going to be able to match them precisely. My participants do not have or do not know what their 9-digit zip code is. I don't even know what my 9-digit zip code is. But I am able to basically generate a kind of aggregate 5-digit zip code national and state level ADI ranking that I think is a pretty good approximation for what would be considered the ADI for my participant based upon their 5-digit zip code. And I'll show you kind of a visual of that to kind of help bolster that explanation. So what I'm going to do here is I am going to list all of the directories, all of the folders within my parent file that has all my ADI downloaded data. And if I show you this here, you can see this basically matches the previous folder that I had showed you, right? And so then what I'm going to do is I am going to pre-allocate 3 variables. 2 of them I'm really only going to use. ADA file is just an empty variable, and USNA, so this is going to be considered the United States Neighborhood Atlas data frame that I'm going to generate. And that's also just going to be an empty data frame, 0 observations with 0 variables. And now I'm going to walk you through how this loop is going to work. So I'm just going to index through from the second file in the directory. You see this one, actually I don't need to use this directory, something else, and I'm just going to go from 2 all the way to 53. And I don't need to know which state is related to what, because I have a method that I'm going to kind of figure that out for myself as I kind of loop through this. Alright, so I'm going to first, I've already run this, but I'm going to set I equal to 2 so that it's as if this loop is running through the very first iteration. So what I'm going to do is I'm going to first take the this second index within my ADI directory list, and that is going to give me my the 2 files within that specific directory, which I showed you earlier. So we're looking specifically within this directory, as you can see, AL, and I'm going to read in just the .csv file. Okay, and so the way that I'm going to do that is I'm going to use the read.csv function, and I'm going to paste together the directory that I'm indexing into, separated by a / within followed up by the second file within that specific directory. And that's basically going to be my call to that directory. And if we visualize that in the console, it looks like this. Oops, what do we do? Oh, too many parentheses. Okay, so this is the call that I'm making within read.csv to import this specific data frame, this specific .csv file, as you can see right here. And then I'm going to use this argument within the read.csv, is this to import everything as a character. And this is important. If I go back to the data before, essentially it's easier to be able to process these data as characters versus numbers, because some zip codes actually start with a 0. And if you read it in as a number, it is going to consider it to be less than what it actually is, right? Zip codes are not actually numbers, they're just kind of categorical variables. And so when I'm going to then kind of get the 5-digit zip code from it, I need to make sure that I am not removing information that I need in order to make sure that that zip code actually is what it's supposed to be. So now with that, I'm going to read in my first .csv file from the ADI. This is going to be the Alabama.csv for ADI. I'm going to store it into a temporary variable that I'm just calling temp. That takes a little bit of a while, but as you can see, it's stored here with the same amount of entries that we saw within the README file and all of the data that we would expect to see within it. And everything is imported as a character. All right. So then I'm going to create another variable within this temporary file that I'm just going to call state. And I'm only going to basically add into all of the data that I've just imported in the state abbreviation so that I can use this later as a type of verification for my merging after the fact. So what I'm going to do is I'm going to take my ADI file 2, which I've imported in previously. We can see it here in the console. And I'm going to use the function substring to just give me the first two characters, which is going to be A and L, the state abbreviation. So when I run that, you can see now in temp that there's a new variable called state, and it spans the entire length of the temp data frame with AL at every observation. Okay, so this will make it easier to now to associate which zip codes are for which state. Then I am going to basically convert the data type for the ADI national rank and the ADI state rank from character to numeric. And what you can see here is that I get a warning message saying that NAs are introduced by coercion. That is because across all 1.5 million plus ADI national and state rankings, some of them are missing. So they are going to be converted to an NA because there is no actual data for specific data frames within the entire database. But that's due to a variety of reasons. They may be too small, they may represent military bases, which don't really have a meaningful ADI rank, or some other reason that I'm not completely aware of at the moment. Then I am going to create another new variable within my temporary data frame called zip5. And what I'm going to do here is I'm going to use again this function substring, and I'm just going to take the first 5 characters from the original 9-digit zip code that we imported in under zip4. So if I show this really quickly, just the top of my temp file, what I can see is zip4. If I take the first 5 digits, that's going to represent probably what is a feasible zip code that I can match, that a participant is going to be able to recall off the top of their head. So I'm going to create this as now kind of the overall kind of aggregate zip code for all of the 9-digit zip codes that include just these first 5 digits. So I run that. We'll display the new data frame again with the new variable, and you can see now that I have just the 5-digit zip code for all of my 9-digit zip codes across all of the zip codes in the state of Alabama. So it gets quite intense pretty quickly. Then I'm going to use the function aggregate to give me the ADI national rank for every 5-digit zip code, which I just created, for each state, just in the event that there's actually more than one state. You'll actually find that doesn't happen very frequently, but some zip codes are on state lines. And so the same zip code will be represented by 2 different states. So this is important to be able to include this state level information so that you'll be able to confirm if in fact the zip code that you're looking at, if it does fall on a state line, is part of one state or the other. So I'm going to just say by state, zip, and state, using my temporary data frame, give me the mean of those. And do the same thing for the state rank as well. In this case, I'm going to use aggregate, but I'm going to unlist this and only really index in the very last data frame, which is the very last variable, which is going to be my aggregate value for ADI state rank. And then I'm going to just row bind them with my empty USNA variable with my temporary aggregate data frame that I've created. And I realize now that I have erased the entire thing that I was looking at, which is okay, because you can kind of trust me that this works. Actually, we'll have to rerun it. Okay, we're going to rerun this to show you how well it merges, and we'll pause and then come back and resume from where we're supposed to be going. Okay, be back in a second. Okay, we are back, and it just finished running. Full disclaimer, it took my computer about a little more than 5 minutes probably to run all of this, but that's going to vary from machine to machine. All right, my computer's pretty good. It has some good memory and good processor. One thing you can notice up here that I want to make everyone aware of, that when you're doing this, you're going to want to be able to run this on something that you think has a good amount of memory. This machine that I'm working on has 16 gigs of memory. And why that's important is because you can see here, just now sitting idly, the amount of data that we've kind of been bringing in and processing is somewhere almost around 3 gigs. So if you're working on a computer that only has about 4 gigabytes, which isn't too common these days, this is going to be a pretty big accomplishment for that machine, in my view. So be aware of where you should really try to run this type of data processing. Okay, so I have now my completed US aggregate neighborhood atlas data frame that only has now 39,995 digit zip codes, which is actually pretty close to what is the actual number of zip codes, 5-digit zip codes in the US. I think it's actually the official number somewhere around 43,000, so we're pretty close there. And so then I'm going to now essentially merge my zip data with this zip data that I've now compiled from the ADI database. So we now have gone through the loop all 52 times. Now I'm going to process my data, and what I have here, as I've shown you previously, my data were not imported in as a character, so I need to handle that. And you can see here that within my data, this is going to be seen, if I just straight converted it to a character, as just a 4 character string. It's not going to assume that this should be 5 characters long and that there should be a 0 leading these 4 digits. So I have to use, again, a for loop to be able to pad front-wise this 4-digit zip codes with a 0 to make them all match up. So I'm going to first just convert them to a string. I don't think that really changes what you can see in here. You can actually see it was shifted from the right to the left. And then I'm going to use this loop to basically add a 0 to any of the 4-digit zip codes that I have. And really, when I say 4-digit, it means the 5-digit zip code that has a 0 in front of it, but it just wasn't imported like that initially. So I'm going to use the function nchar. So I have n equal to 1397 observations in my zip data. Of course, the better way to do this is say length of my zip, or dim, and the dim function myzip on the index of the observation. So I think that'd be dim1, but I just kind of hard coded in here just because I'm lazy. Anyway, so we're using the nchar because we converted this to characters. It's going to tell me how many characters are in each of my 5 zip codes, and any of them that are less than 5, I am going to paste a 0 in front of it with a separated by nothing, so no space or anything in between it. So I'm going to run this really quick, and now we can look back into my zip, and we can see now those 4-digit zip codes that did not have a leading 0 now have that leading 0. Now the only thing I'm going to do is I am going to merge my data my zip data with my now aggregate USNA data. Actually, before I do that, and I don't think this line is actually necessary, I am going to show you a kind of proof of concept that by doing this aggregate measure, we get good agreement between what is the 9-digit zip code national rank versus the 5-digit zip code national rank that is averaged across all possible 5-digit zip codes among all the kind of congruent 9-digit zip codes. Okay, and so this was the data. This is something that I ran here. Marked out is essentially I merged the temp file with my temp aggregate file here, and then I visualized it across what would be the aggregate level on the x-axis with the 9-digit zip code on the y-axis. And I saved it, and we can look at it here. And what you may, it's so much data here, it actually takes some time to render. What you can observe here is that it has a pretty good linear trend to it. Obviously there's quite a bit of noise, but we're not seeing that the case is there's too many instances of when the average ADI is representing a kind of a high skew to itself, or it has a lot of outliers here, where something that's supposed to be low is actually ranked quite high. That doesn't happen too often. Again, this is out of 1.5 million different zip codes. And it does really well for things that aren't actually high. It doesn't treat them as high on the average level either. One thing you may consider is that I'm using the mean here. You might consider using the median. That could be dependent upon that if there is some skew to the data, the mean as a measure of central tendency might not be as representative compared to that of the median. I hadn't done that there. That might be an interesting thing to try. There might be other things to try that might also be super helpful. But for overall, I'm okay with this in my regard, and being able to demonstrate that if you take the average across the 9 zip codes and convert them kind of average them out to 5 zip codes, which is represented on the X here, it's going to match pretty well and represent pretty well what we see across all of the 9-digit zip codes, which is what we see on the y-axis here. So now all I have to do is merge them. I'm going to create a new data frame called zip ADI. I'm going to merge it with my US neighborhood atlas data frame that I created from the first loop, and with my zip data that I imported in initially and have processed using the second loop by the variable zip5, which each of them have. So zip5 in here and zip5 in here. When I run that now, I get zip.ADI. I have 1,384 matches, and 1,384 divided by 1,397 demonstrates that I was able to successfully merge 99% of what was in the ADI data to that of my own data. And I can look in and see exactly where are the not matches occurring. It could be because something was recorded improperly, or one of the cases where the zip code just doesn't exist within the ADI database. So there's always a way to kind of go back and reverse engineer these things to make them even a little bit better. But 99% on the first try is not too bad in my mind. So let's go ahead and look at this now. And what I can see here is I have state.x and state.y, so it replicated that variable because I have state in both of them. So in my zip I have state, and then in the USNA I have state. So kind of a quick sanity check that I can do is I can go table, zip, oops, ADI, state.x, my zip, ADI, state.y. And what this will tell me is that if I have something where these things do not match up across the states at the very least, then I can look back and see what things I need to change or remove it altogether. Whoa, that's a lot. But you see it's all going across the diagonal, which is good. I don't see any instances. Oh, there's one. Okay, so that was one that I might want to look into. It's a zip code that says that is from the state of Kentucky, but also from the state of Indiana. Those do not border each other, so that's an interesting one to look at. And other things I'll probably have to look at to be. But again, it seems like it has pretty good agreement across the diagonal, which is good as well. But another thing to be able to look at to be able to remove data as you go or be able to improve the algorithm. But overall, this seems to be a pretty good match to what I'm seeing here. And I can kind of see that face validity wise as well. Where's that Kentucky one? Oh, here's no. One of these. Anyway, I wouldn't do it visually. There's ways to do it programmatically as well. Well, that concludes my kind of demonstration of how to use R to be able to merge the neighborhood atlas derived from the Center of Health Disparities from the University of Wisconsin School of Medicine and Public Health. Big promotion for this because it seems like it would be an incredible amount of work to generate this atlas and do what they do and then make it open access, and to be able to then use these data for your own use to be able to understand now how does socioeconomic disadvantage impact variables related to potentially rehabilitation or other clinical usage. I think it can be quite impactful. So I hope you find this interesting. Again, this is a tutorial I am doing for the ReproRehab, and if you have any questions, please feel free to reach out, and I'll be continuing this series. With the next one I'll be doing is merging data with the air quality index recorded from the Environmental Protection Agency. Thanks. Bye-bye.